Computers are incredibly good at the things we find difficult, like calculating the exact trajectory of this rocket in a fraction of a millisecond. But historically, they've struggled with things humans find easy, like telling the difference between a chihuahua and a blueberry muffin. This is because traditional software works like a strict baking recipe. A human developer has to sit down and write out every single step perfectly for the computer to follow. As long as that recipe is followed to the letter, the output is guaranteed. This rigid precision is exactly why computers excel at math. The machine has no room for interpretation. It simply does precisely what it has been told to do by a human. But recipes fail when things get messy. Consider a bank trying to spot a fraudulent credit card transaction among millions of legitimate ones. A human programmer would find it impossible to write a specific rule for every single trick a thief might use to steal your information. Standard if-then logic eventually hits a limit. It can't adapt to slight variations or weird edge cases, quickly turning into this tangled, chaotic web of unreadable rules. Defining normal human behavior is far too nuanced for a checklist. There are just too many shifting variables for a human to account for. When a problem becomes this unpredictable or subjective, the traditional recipe-based approach hits a wall. To solve these messy problems, we have to work backward. We've moved from writing the instructions to a process of learning from examples. Instead of giving the computer a set of rules, we provide it with the raw data and the final answer, then ask the machine to figure out the connection itself. Think of it like a professional taste tester. They don't learn what makes a cake good by reading a recipe. They learn by physically tasting hundreds of them until they develop a natural intuition for the right flavors. The AI goes through a similar process using digital flashcards. It looks at data, making a blind guess. It checks an answer key, and if wrong, mathematically adjusts its settings to be more accurate. This cycle repeats millions of times at high speed until errors disappear and it settles on a pattern. The AI hasn't memorized a rulebook. It has built a mathematical intuition for what normal looks like, based entirely on repetitive experience. This pattern matching engine is the same technology behind large language models like ChatGPT. Despite how they sound, these models do not have thoughts, intentions, or a mind. They function much like the predictive text on your smartphone, which predicts your next word based on what you've already typed. An AI chatbot does this on a massive scale, having analyzed trillions of sentences to understand the relationships between words. When it answers a question, it calculates the statistical probability of the next word based on all the human writing it has seen. Beneath the surface, it's playing a high-speed game of fill-in-the-blank. This leaves us with two different tools. Traditional software gives us mathematical certainty, while AI gives us statistical confidence. Because AI is built on probabilities and guesswork, it is naturally messy. If you give an AI the exact same prompt twice, you might get two different outputs. We can think of this as probability as a service. It's a system where scattered data points swarm together to reveal a recognizable pattern. Moving away from strict rules is actually a massive advantage, allowing computers to tackle the nuanced gray area problems that standard software couldn't touch. Try viewing your AI tools as highly experienced detectives. They are scanning for subtle clues and identifying patterns that follow the messy logic of the real world. Seeing AI as a pattern-matching engine clears away the magic, leaving us with a practical tool for navigating an unpredictable world.